So the first group can be any pattern. I'm just asking you to find the pattern and give me the next three terms. This is not necessarily arithmetic. In this case, actually, I think this one is, right? But it could be just, you could be it could be squares. You could have 2 squared plus 4 squared plus 6 squared. I mean, it could be something like that where you just find the pattern and give me the next 3 in the pattern. That's how simple that is. Then you get into specific types of sequences and series. This one specifically, if you see common difference, that's an arithmetic. So all of those formulas start on page 457, and then you get into series after that. So 457 is where you're going to see these formulas. To find common difference, you're just going to subtract 2 terms. So to find my common difference, I could just take the negative 13/4 and subtract the negative 7/4. I'm going to get negative 6/4, and yes, you do reduce that, negative 3/2. So that's my common difference. I have my first answer there. I actually go to recursive and then to explicit and then to the 52nd term. So recursive form, if I want to find a sub n, I take the 1 in front of it, that's a sub n minus 1, and I add my common difference. So that's recursive. How do I get from one to the next? Well, your common difference tells you that. Explicit. Your explicit formula is always going to be the same for arithmetic ones. You're going to say, if I want to find a specific term, I'm going to start with my first term. So my first term here is negative 7/4. And I am going to add whatever term I'm on minus 1 multiplied by my common difference that I've already found. You do want to simplify this. Like, don't leave it like this. Simplify it. You're just doing basic algebra to simplify. Distribute. You get negative 7/4 minus 3/2 n plus 3/2. Combine your like terms. When you combine these, you get negative 1/4. So a sub n equals negative 1/4 minus 3/2 n, or vice versa. You could put negative 3/2 n minus 1/4. It doesn't matter. And that is my explicit. So that is my next one that I have found. The last thing it's asking for is the 52nd term. It's easiest once you find explicit, then go to the 52nd term. A sub 52 then would just be negative 1/4 minus 3/2 times 52. You're going to get a really big fraction here. You get 26 times 3, multiply, get a common denominator, and then add it to the 1. All right, so the first thing it wants is the common ratio. For the common ratio, you divide them. So you're going to say the second term divided by the first term. All right. I go to my recursive next, just because I find that an easier order to do it in. So my recursive formula then, to go from one term to the next, I'm going to take the term in front of it and multiply by negative 6. And you can leave it just like that. Explicit. For explicit, to find a sub n, I am going to start with my first term. In this case, it's negative 3. And I'm going to multiply that by my common ratio to the power of n minus 1. And then they want the 8th term. So I'm just going to plug in an 8. Negative 3 times negative 6 to the 7th. These are going to be some big numbers on this one, and on all of these usually, unless it's a big fraction. But you're taking things to a power, so don't get thrown off if you have a really big number here or a really big fraction, because you are taking things to a rather large power when you have it to the 8th there. And that's a 7, by the way, not an n. It's 8 minus 1. So you are using your formulas, whether it's arithmetic or geometric, to back into your common difference, which I apparently erased, your common difference or your common ratio. And then you're using the common difference, you're just adding that to get across. Common ratio, you're multiplying by that to get across. So if it says evaluate the series, that means add it up. We're adding this up. Add up all the terms. That's what series means. When it says evaluate the series, you're going from the first term to the last term and adding them all up. So my summation is going to be my number of terms that I have, 13 over 2, times my first term plus my last term. All right, that is for arithmetic only. Arithmetic only. And you may get some big numbers here or fractions depending on what you have going on, but you are adding up all the terms. All right, so we do have to figure out what my common ratio is here. So you can take any two terms and divide. So negative 2 divided by negative 0.5, negative 8 divided by negative 2. You're going to get the same thing every time. You're going to get 4. So common ratio here is a 4, right? And then you want to plug it in pretty much. So you're going to say my first term, which is given to me, negative 0.5, 1 minus my r, which was 4, to the n, which they also gave to me, all over 1 minus my r. All right. So this is going to end up being negative. We have a negative, and a negative. So you will have a negative number here, which is fine. And you can just plug all that in. Like you can literally do that in your calculator. That's fine. You do need to show me this piece because if you plug it in wrong and you didn't show me what you did, that's all your credits. So now they're not asking you for the total. They're asking you how many terms did you add up, but they gave you the total. So you're literally doing the same thing, but you're plugging it into another place. So if I know that my summation is 290, I don't know my number of terms. I know my first term and my last term. I'm literally just going to solve there, right? So I'm going to add those 58. I'm going to divide by 2 and then divide across to the 290, and you're going to see that you have 10 terms, okay? So when you just, at this point, you're just doing algebra, right? And so how many terms did I add up? I added 10 terms. So this is the same thing. You're just finding a different variable pretty much in the same formula. And the same is true for the next one, for the geometric. If you look at the next group, you're doing the same thing. They've given you your total. We know that it adds up to 2343. We know my first term, which is the 3. We can figure out the r, right? Just divide. 15 divided by 3. So we know that we have 5 to some power. over 1 minus the 5. And so you're going to do the same thing. You're going to multiply by your denominator, divide by that 3, subtract over, and then you're going to have to take a root, right? So, or a log, you can do a log if you want to get rid of it, but either way, you're going to figure out that you have to solve for the variable here. I mean, for the exponent, which is in the variable position. So for infinite series, the only way you can actually give me a number here is if your R is absolute value less than 1, okay? So if this right here, the absolute value is greater than 1, your answer is just going to be, this is a divergent series. Divergent, you can't give me a number, right? If your R absolute value is greater than or equal to 1, all right? If your R is less than or equal to 1, then you can use your formula, which is just your first term over 1 minus R. So this one I can do because 1/5 absolute value is less than 1. So I would just say my first term, 93/75 is my first term, over 1 minus my R, which is negative 1/5, right? So this is going to be a really big fraction, or you can, I don't care if it's a decimal because this works out to a nice decimal as well, but